All right, today we're going to look at integers, rational numbers, and absolute value. Integers are the set of whole numbers and their opposites. So the whole numbers begin with 0, 1, 2, 3, and so on. And the opposites of those are -1, -2, -3, and so on. And what I'd like you to make note of is the fact that when we have integers, when you simplify them, they can have no decimal part, and they can have no fraction part. And we'll see some examples of this in a moment. Rational numbers can be written as a fraction of a over b, where a and b are integers, and b is b is not equal to 0. So when we look at this, integers, some examples would be things like -1/2. 1/2 you should know is 0.5, and that's negative because we said it's -1/2. Likewise, if we did something like let's do -1/3, that'd be -0.3 repeating. These numbers don't always need to be negative, and so let me give you another example here. Let me do 5/4. And I want to make sure that you see this, that as a decimal, this is 1.25. So rational numbers include the decimals, and more importantly, when they include the decimals, they are two types of decimals. They're the ones that terminate, and there's the ones that repeat. So the two types of decimals that you'll see with rational numbers are the ones that terminate or the ones that repeat, and those can all be written out as a fraction of integers. So looking down at a couple columns here, just to make sure that we've got this idea, decide whether the numbers are integers or rational numbers or both. I'm not going to worry about the both part. All integers are rational, and what I'm more concerned with is, can we tell the difference between a specific integer or whether or not the number is rational? So basically, if it's not an integer, it's rational at this point in your math career. So 4 is an integer because it's a whole number. -3 is an integer because it's one of the opposites of the whole numbers. 1 1/4, though, is rational because it has a fractional part. 7 is a whole number, so it's an integer. -5/3 is rational because it has a fractional part. -2.6 is rational because it's a terminating decimal. -2.5 is rational because it's a terminating decimal. 3/2 is rational because it's a fraction. 9 is a whole number, so it's an integer. And -1/4 is rational because it's a fraction. So the absolute value of a number is the distance between a number and 0 on a number line. The absolute value is always written as a vertical line, and then the number, and then a vertical line. I should also make mention that absolute values are always positive. Examples. Absolute value of 4 is 4, because 4 is 4 units away from 0 on a number line. If I drew a number line, 0, 4 is 4 units away. On the other hand, if I did absolute value of -4, that's also 4 because -4 is 4 units away from 0 on a number line. So just practicing this concept really quickly, remember absolute values are always positive, so the absolute value of -3 is 3, absolute value of 1 1/4 is 1 1/4, absolute value of 7 is just 7, absolute value of -5/3 is 5/3, and absolute value of -2.6 is just 2.6. So now we're asked to compare two numbers. Well, right now we're trying to compare apples and oranges. The numbers are not in the same format. One's a decimal, one's a fraction, which makes things somewhat difficult. So I'm going to change 3 halves into a decimal. I do that by dividing 3 by 2. 2 goes into 3 once. 1 times 2 is 2. We subtract. 3 minus 2 is 1. We drop a 0. Put the decimal point up there as well. 2 goes into 10 5 times, so we have 1.5. So what we're really comparing then is the absolute value of negative 2.5 compared with the absolute value of 1.5. And so then what we need to realize is that what we're also then doing is we're saying the absolute value of negative 2.5 is 2.5, and the absolute value of 1.5 is 1.5. And therefore we know that 2.5 is bigger than 1.5. It's greater than 1.5. So therefore the absolute value of negative 2.5 is greater than the absolute value of 1.5. Comparing rational numbers, the absolute value of 9 is 9, and the absolute value of negative 9 is 9. So that means that those two absolute values are equal. Over here, this is where you need to pay attention. This is the opposite of the absolute value of 1/2. The absolute value of 1/2 is 1/2, and we want the opposite of that. The opposite of any positive is a negative. Now we look at this, and if we were to draw this on a number line, if we were to go 0, the first number we would come across would be the negative 1/4. The next number we would come across is the negative 1/2, because the negative 1/2 is on the left-hand side, leftmost side. Negative 1/2 is less than negative 1/4. And so therefore the opposite of the absolute value of 1/2 is less than negative 1/4. Over here we have 7, and here we have the opposite of the absolute value of negative 4.5. The absolute value of negative 4.5 is 4.5. The opposite of that is negative 4.5. And just as a quick comment, positives are always greater than negatives. So 7 is greater than negative 4.5. So 7 is greater than the opposite of the absolute value of negative 4.5. The last thing to do is to see how we can use this in a real-world problem. So a moon has an ocean underneath its icy surface. Scientists run tests above and below the surface. The table shows the elevations of each. We have a temperature test, a salinity test, atmosphere, organics, and ice. We want to know which test is the deepest. That's the salinity test, because it is the most negative. If you were to put this on a graph, salinity would be way down here at negative 5.15. 0 would be here. Negative 3.8 would be probably right about there. Negative 4.5 is down here. And then you'd have your negative 0.25, and then you'd have your 0.3. So we can see that the salinity test would be all the way down at the bottom. Now, which test is closest to the surface? The surface is 0. And which one's closest to the surface? Well, we're looking between atmosphere and ice. The answer is going to be ice, because the 0.25, let me show it this way. The absolute value, because when we're asking which one's closest to 0, we're asking an absolute value question. We're comparing the absolute value of these two numbers. And sometimes students get confused with this because they say that, oh, the 3 has less decimal places. So the 0.3 has less decimal places, so it must be smaller. That confuses students from time to time. So let me show you some things. The absolute value of negative 0.25 is 0.25. The absolute value of 0.3 is 0.3. But because they're not the same size of decimals, let's throw a 0 on to the 0.3. Now we can see that this is 0.25 or 0.25, and this is 0.30. we know that 30 is greater than 25, and so therefore 0.25 is less than 0.30, which makes the ice test closer to the surface than the atmosphere test. So this has been our discussion about integers, rationals, and absolute value.